Hi everyone, today we are learning about ratios, the moment you have all been waiting for. So we need a definition for what a ratio is. Ratios, they show the relationship between two quantities or numbers. So fun fact, you've actually been working with ratios since kindergarten or first grade when you used to have like complete the pattern problems where it said complete the pattern and it would give you a star and then two hearts and another star, and then they would say, okay, what would the rest of this pattern be? And your little kindergarten or first grade brain would go, oh, I think it's two more hearts. This is actually a ratio. What we have here is a 1 to 2 ratio because you've got one star and then two hearts, and one star and two more hearts. So ratios can be used to represent patterns. So for example, in everyday life, we use ratios when we're cooking. So it says a recipe calls for 3 cups of sugar, 3 cups of sugar and 5 cups of flour. I'm going to use a different color for that because that's going to be more helpful to us. Okay, 5 cups of flour. So there are actually 4 different ways to write ratios, and you're going to see them written all 4 ways. So first is with a colon. So we have 3 cups of sugar to 5 cups of flour, and the colon is just a way of representing the word to. So this is not like time on a clock. This is representing a ratio. So 3 to 5, 3 to 5, and as a fraction, 3 to 5. This is something called a part to part ratio because you're comparing two different things. We've used fractions before, but that was a part to whole comparison. So before you've worked with part to whole comparisons, for example, if Miss Dixon ate 3/5 of the pizza, that is 3 pieces out of 5 pieces. The whole piece is 5. So just be aware that fractions are usually used to represent part to whole comparisons, how many pieces out of the whole thing, but they can also be used to represent ratios, in which case you might be comparing two different things that aren't related to each other, like sugar and flour. Those are two different things. Then you can also write ratios in words. For every 3 cups of sugar, there are 5 cups of flour. We actually did that earlier this week when we were working with comparison statements and the fundraising goals. Now, you can also flip-flop the ratios and write them in a different order. So now we're going to talk about flour to sugar ratios. We're still working with the same example, but the order switched around. So now we have a 5 to 3 ratio, 5 to 3 ratio here, 5 to 3, and then for every 5 cups of flour, there are 3 cups of sugar. So make sure you are paying attention to the order of the problem, that was weird wording. Pay attention to the order the problem tells you to use for the ratio. Otherwise, you can get mixed up and then all your numbers will be wrong. You can pause the video here if you want to take a look at what a ratio table is and what equivalent ratios are. We'll be learning those next week, but you might still want to get a little preview of what they look like. All right, time to do some examples. So they give us the statement there are 3 boys for every 4 girls in the 6th grade. Write the ratio of boys to girls, all 4 ways. And we want to keep that order. The order in which we write the ratio is important. So all 4 ways we need a colon. You can write it with the word to. You can write it as a fraction, and then finally you can write it as a sentence. So let's start with the sentence first, since that's what we already have experience with. So we can write for every 3 boys. In the 6th grade, there are 4 girls. Simple enough. And that is a 3 to 4 ratio. So we can write that in words, 3 to 4 ratio, boys to girls. 3 to 4. So just as a reminder, the colon represents the word 2. So we read this out loud as 3 to 4. 3 to 4. And then we write it as a fraction, 3 to 4. So just as a friendly reminder, this is a part-to-part relationship because we're comparing 2 different parts of the 6th grade. We're comparing the boys to the girls. This does not mean 3 out of 4 boys, girls. We wouldn't know which unit to use. So this is a part-to-part relationship. Undo. I guess I could have left that there. Oh well. Okay, so moving down. There is an example here. You can create a ratio table if you want, but that'll be next week. So we're going to skip just to the next example. Okay, example number 2. For every 6 shirts sold, a store sold 10 pants. So 6 shirts, 10 pants. Write the ratio of pants. Oh, pants is coming first now. Okay. Write the ratio of pants to shirts all 4 ways. So we need a colon, a word 2, and as a fraction. Let's do the sentence first. Notice how they tried to trick us. They're having pants go first this time, followed by shirts. So we want to write for every 10 pants sold, because pants has to come first, 6 shirts were sold. And we're going to write this as a ratio, pants, number of pants coming first, so 10 to 6, 10 to 6 in words, and then as a fraction, 10 to 6. It's another part-to-part relationship because these are 2 different quantities. You can't have 10 out of 6 shirts. The 10 represents the pants. So it's a part-to-part relationship. Let's see, what else did I want to talk about? Oh yeah, in this example, we also have something called equivalent ratios, which we haven't learned about yet. Just how you can simplify fractions, you can also simplify ratios. So the greatest common factor of 10 and 6 is 2. You can divide each of these numbers by 2 to get a simplified version of that fraction. So when you divide each of these numbers by 2, you get 5 over 3. So this ratio can also be a 5 to 3 ratio, a 5 to 3 ratio. For every 5 pants sold, 3 shirts were sold. So equivalent ratios. It's a little preview for next week.